Okay, back again, and debate about whether to do this video or not, but I got some pretty good feedback from the first video, and this video, what I want to do is kind of show an alternate method to solving addition of vectors in 2 dimensions. So this method's called the parallelogram method, and it's not my favorite method by any chance. It's usually the reason I don't teach it. I don't like it as much as I do the tip-to-tail method, but I thought I'd go ahead and show you guys just another way of doing it, and then let you kind of decide which way you want to. Okay. So we're going to use the same vectors that we had in the very last video that I did, and those vectors were 40 meters at 32 degrees, and then the other vector was 20 meters at 170 degrees. Okay, so the parallelogram method is very different from the tip-to-tail method that I showed in the last video. Okay. First off, when you sketch your vectors, you want to sketch them so that they are tail to tail. Okay, so what do I mean? Well, let's take a look at the very first vector. Okay, so this is my 40 at 32. Okay, I'll go ahead and I'm going to do this one in the color red. Okay. Okay, and I'm going to put its tail next to the tail of the other vector. Okay, and the other vector was basically 20 at 170. So something like that. Okay, so just kind of so we know they're color coded. That one's that color and this one's this color. Okay, so we have orange and red, and hope they show up pretty good. Okay, so when you're doing the parallelogram method, basically what you do is you construct a parallelogram, and what we're going to do is we're basically going to take the vector and kind of make a mirror image. Okay, that looks, a little bit like that. Okay, and I'll go ahead and color code them. So that's my orange, and then that one's my red. Okay. All right. So what you do then is the line that we're going to solve, which I'll do in yellow, is going to be a line that extends from where the two vectors touched originally and to where they touch after we do that little kind of mirror image to make the parallelogram. Okay, so we have this little yellow line. Okay, that yellow line is going to be our resultant. Okay, also to make it a little easier, I'm going to call that one vector A and that one vector B, so we can kind of see what we're talking about here. So that's my A, that's my B, that's also an A, and that's also a B. Okay. So one of the first things we're going to do, just like we did on the other method, is we're going to find the length of that resultant. Okay. And the way we do that is we're going to use something called the law of cosines. Okay. The law of cosines looks like this. Okay. R squared is going to be equal to A squared plus B squared minus 2AB cosine of R. Okay. Alright, so what are we talking about when we do that? Well, this is what we're looking at. A, of course, is A, B is B, R is R, and then the cosine of R is going to be whatever this little angle is right here. Okay, so I'm going to call that angle R, or theta R. How about that? So we'll call that one theta R as well. Okay, let me zoom out just a little bit for you guys. Okay, hope that's a little bit better. Okay, so what we have to do is we have to do a little bit of trigonometry and a little bit of geometry, just kind of like we did last time, but probably even more. Okay, so the first thing we want to do is we want to try to figure out what the angles are inside of our parallelogram. Okay, like with squares, the angle inside of all the angles have to add up to 360. Okay, so the first thing we're going to try to figure out is what is the angle between the two vectors, and that part's actually really easy. Because if you look at the two angles, 170 and 32 degrees, the angle between them is going to be the difference. Okay? So this angle right here is going to be equal to whatever 170 minus 32 is. Okay? And if my math is correct, that should be about 138. Okay, so that angle is 138. Okay? This angle is also 138. So 138 and 138. These two have to be the same angle as well. So to figure out the missing angles, remember what I said earlier, all angles had to add up to 360. We can do 360 minus 138. Minus 138. Okay. And if we do that, we get 84. Okay. So both of these angles combined have to be 84, which means each of them is going to be half that. So this is going to be 42 degrees, and that one's going to be 42 degrees. So our cosine, our theta that we're looking for is 42 degrees. So here we go. Let's go ahead and do the math then. Okay. Vector A is 40, so this will be 40 squared. I left off a square there earlier, I just noticed. Sorry about that. 40 squared plus 20 squared minus 2 times 40 times 20 times the cosine of 42 degrees. Okay, is going to be equal to r squared. Okay, so let's go ahead and do the math that we've got here in front of us. So 40 squared is 1600. 20 squared is 400. Okay, 2 times 40 times 20 is 1600. So 1600 cosine of 42. Okay, let's keep on doing the math. So cosine of 42 is 0.743. I'm going to go round right there for right now. And that'll be multiplied by 1600. Let's go and do that one. That's 1640. Okay. So we have 1640 minus. Okay. 0.743 times 1600. And that equals 1188.8. Once again, keep doing the math. 1640 minus 1188.8. 16 minus 11. Okay. All right. Let me do some calisthenics real quick. All right. Lights back on. All right. 451.2 r squared equals. Okay. So r equals the square root of that. 451.2. Okay. And that comes out to 21.24. Okay, so 24.241. Okay. All right. So according to that, that's our resultant. Okay. I realize I've just made a mistake. So let's go back and see where I made a mistake. And if you're paying attention to the video, you probably caught it long before I did. Let's go back up right here, what I did. Okay. Like an idiot, I said 20 squared was 40, and that is obviously not correct. That should be 400. So this total right here should not be 1640. It should be 2,000. And that should be 2,000. Okay. Of course, that's going to make all of those wrong. All right. So 2,000 minus 1188.8 equals 811. So r should be equal to the square root of 811.2. Okay. Alright, so if I do the square root of that, then I get the correct answer of r equals 28, let's just say 28.5 meters. Okay, so that is the correct result. Now, I apologize. Like I said, I don't do multiple takes on these videos, and to err is human, right? Okay, so that is the length of our resultant. Okay, so we have the magnitude of our vector. Now we got to do the angle of our vector. And to do the angle of our vector, we're going to use something called the law of sines. And this is how the law of sines works out. Okay? I want to try to figure out technically what this angle is right here, which will be added to that angle right there. Okay? We know from earlier that since this vector is at 32 degrees, that this angle is going to be 32. Okay? So whatever this new angle is, we'll call this one theta 2 to keep it squared from the one we did just a moment ago. Okay? So theta 2 will be what we're trying to solve. Okay? So the way the law of sines works out in this particular case is we're going to take the sine of the angle that we determined just a little bit ago, 42, and we're going to say the sine of 42 over what we just solved just a second ago, 28.5. Okay? And we're going to set that equal to the sine of theta, which is our unknown, we'll call it theta 2, over the length of b, which is 20. Okay? Alright, so this is what we're going to end up with. If we do a little bit of math, we're going to get 20 times the sine of 42 over 28.5, and then do the sine inverse of that answer, and that's going to equal our theta. Alright, so let's try that out then. So 42 sine times 20 divided by 28.5. Sine inverse of our answer is 28. Okay, so 28. And if we do 28 plus what we said a moment ago, 32 degrees, 28 plus 32 equals, well, 60 degrees. Okay, so this full vector that we just determined, if we package it up like we talked about in class today, remember when you package it up, you want it to be nice and pretty, so whoever's looking at your work can see it right away.